So if you want to see the explanation of these three simplification problems, please watch the previous video that I already posted, because we're going to move on. So simplifying these is very important because it's pretty much the last couple of steps on the class opener, last couple of steps when we apply the quadratic formula. And I do explain that on the other video. Please watch it so you can get a better understanding of simplifying. On the other video, I also explain that the quadratic formula is like a tool that could be used for anything, all right? So let's actually start using that tool on the worksheet. So check it out, guys. The quadratic formula is your most important tool. You should write it down somewhere. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. You need to have it memorized, right? This tool will work on any problem, right? It's kind of like having that Swiss Army knife. You could use it to cut a piece of paper, to clip your nails, to measure something, to open up a bottle or a can. It'll do anything, right? This quadratic formula will solve anything. However, there's some tools that are nicer, right? Let's all take a look at number one right here. Would it be a good idea to use a quadratic formula on this one?
Probably not.
I mean, we could use the quadratic formula. Our a value is 7, our b value is negative 5, and our c value is supposed to be right here, but it's not. So that would mean that the c value is 0. So I could use the quadratic formula if I wanted to, right? But do you have any other tool that might be easier for this one? Pull out a GCF, right? Check it out. If I pull out a GCF, which would be x, what would be left over on the inside? 7x minus 5. So now I truly have this equation that says this x times this 7x minus 5 equals 0. I could use the zero product property to split them and solve. X could equal 0, and 7x minus 5 could also equal 0. And then I solve both of them. This one's already solved for me. The other one, after adding 5 to both sides and dividing by 7, I'll get the answer 5/7 and the answer 0. So those are my two answers. If you look at the back of the worksheet, the answer number one is 0 and 5/7. Okay? So even though right here it says solve each equation by using the quadratic formula, I'm not going to force you to use that one specific Swiss Army knife, right? I would say solve some equations by using the quadratic formula. Now, will the quadratic formula work? Yeah, it will. All right, but it was pretty easy to do it with the GCF. I think easier, right? But let's say you forgot all of the factoring methods. You could use a quadratic formula on any equation. It doesn't matter how crazy it looks, whether it has fractions or decimals, you could use a quadratic formula on anything, all right? Number 3 right here. Well, first of all, it's not ready to go. I need to make it equal to 0 first. So let's subtract 3. Subtract 3. Rewrite it. You're going to have 3x squared plus 8x minus 3 equals 0. So do I have any other tools that I could use? Well, maybe I could go a times c and then think of the multiples that combine together to give me 8. And I could factor using that other factoring method, right? But I'll be honest with you, whenever I see an a value that's not 1, I'll just jump right into the quadratic formula. That way, because even if you did try to factor, it might not be factorable, which means that you have to use a quadratic formula anyway. So the only time I would actually use a different method is if it's a simple one like this guy where you could just, factor out an x. Or maybe if my a value was 1, then I would try to factor, split, and solve. But right here, the a value is 3. So let's just identify the a value of 3, the b value of 8, the c value of negative 3, 3, 8, and negative 3. And let's use this guy, the quadratic formula, but with parentheses instead of the variables to plug them in safely. So let's plug in our b value of 8, b value of 8, the a value of 3, a value of 3 down here as well, the c value of negative 3. Okay? Let's work on our discriminant. 8 squared is 64, so you're going to have, I just like to write the 64 on the side, and then I go through and multiply. What's negative 4 times 3? That's minus 12. Minus 12 times minus 3, that's a positive 36, huh? Now, if I combine 64 and 36, what do I get? That's 100. I get 100, right? So what I truly have is the negative 8 in the front plus or minus the square root of 100 divided by 6. So if somebody asks me, am I going to have, if somebody asks me, will this parabola cross the x-axis one time, two times, or not at all? I already know my discriminant is positive. I know I'm going to get two real answers, so I would say it crosses two times, right? Anyway, let's do the math. What's the square root of 100? 10. So I really have negative 8 plus or minus 10 divided by 6. So that's really two situations. Negative 8 plus 10 divided by 6. And also negative 8 minus 10 divided by 6. So up here, negative 8 plus 10, that's 2. 2 divided by 6, that's simply 1/3. You reduce it, there's your answer. And the other one, negative 8 minus 10, that's negative 18 divided by 6. That's going to be negative 3 as your other answer. So your two answers to number 3, x equals 1/3 and x equals negative 3. Those are your answers right there. Very easy to use the quadratic formula, right? So we need to start using the quadratic formula. Again, the only time I would not use it is if I see a way easier method, right? So should I keep going or should I jump around to different problems? You want to skip 5? 7. All right, 7 is interesting because I see that my a value is 1. So immediately I want to try this. What times what is c that if I combine together is b? Now, if you think about that, it doesn't work, right? So, but it's still good to try because it only takes a couple of seconds to see if it works or if it doesn't. Imagine if it did work. Imagine if this was a minus 4 instead of a minus 6. Then you'd be able to plug in a negative 3 and a negative 1, and then you split them and solve, and you get your answers quickly, right? So it's always a good idea to try to factor. If you think you could factor, try to do it, but right here we see that it doesn't work. What times what is 3 that if you combine together is negative 6? It doesn't work. It's not factorable. So we are forced to use the quadratic formula, but then the quadratic formula is great. It's not that bad. So let's do the quadratic formula again. Quadratic formula is negative b plus or minus square root of b squared minus 4ac divided by 2a. And we're going to use parentheses to plug in those a, b, and c values. So the b value is negative 6. B value is negative 6. A value is 1. A value is 1. C value is 3. Let's begin to work on our discriminant first. Negative 6 squared, that's positive 36. Bless you. So I have a 36 that I write on the side. And then I go, what's minus 4 times 1? That's minus 4 times 3, that's minus 12. So I really have a minus 12 right there. I'm almost done with my discriminant. And yes, I have a positive 6 plus or minus right in front of it. And yes, I have over 2 on the bottom. But let's finish up that discriminant. What's 36 minus 12? 24. So I really have, let me rewrite the whole thing. X equals 6 plus or minus the square root of 24, all divided by 2. So the square root of 24 on the side breaks down to 4 times 6. You split the root. Square root of 4 is 2. Square root of 6 stays the square root of 6. So I'm just going to replace that with the square root of, or 2 square root of 6. I want to replace the square root of 24 with 2 square root of 6. So let me do that. We have 6 plus or minus 2 square root of 6, all divided by 2. So that is the correct answer, but we could reduce that answer, right? And you have to reduce that answer. You reduce it by what? By 2. So 6 divided by 2 is 3. 2 divided by 2 is 1. 2 divided by 2 is 1. So what's my final answer going to be? X equals what? 3 plus or minus 1 square root of 6, or just square root of 6. You don't have to put the 1 in front of the square root of 6, and you don't have to put the 1 in the denominator. There's your answer. X equals 3 plus or minus square root of 6. If you check your answer in the back, you'll see that that's correct. So the quadratic formula always works. Yeah, try to do other tools, try to use other tools, but in this case, no other tool works. Even if you tried factoring with a different method, it wouldn't work. It's not factorable. Quadratic formula always works. Okay? So let's jump around here. Continuing on, number 9. Would you use the quadratic formula right there? No way. I mean, you could, right? If you wanted to, you could add 54, that would be your C value, positive 54, your A value would be 3, your B value would be 0, and you could use the quadratic formula. But this is like way easier to just solve the way you normally would by getting rid of things by doing the opposite. So I'd get rid of the 3 by dividing by 3. I'd have x squared equals, I believe that's a negative 18. So I apply a square root, I'll end up with x equaling plus or minus, but the square root of negative 18 on the side, the negative will come out and it'll become an I. And then you split the 18 to a 9 times 2, so you could get a perfect square 9. That way you'd have I times 3 times the square root of 2. And then arrange it accordingly, 3 first, I second, square root of 2 at the very end. And that's your answer. X equals plus or minus 3I square root of 2. So that was really easy to do. And believe it or not, you would get this same exact answer if you did the quadratic formula, but I think it would be way harder to do the quadratic formula. But you could do the quadratic formula on any question, on all questions. You could use the quadratic formula to solve. Okay, but here's another example where there's other tools that work more effectively than the quadratic formula. Pick one, 11, 13? 13. What do I need to do first before using the quadratic formula? Set it equal to 0. So let's subtract 4x and also add 15. I'm doing 2 steps in one. So I am going to subtract 4x and add 15. Right? That's what I did. I subtracted 4x. I added 15. All I'm doing is moving everything over to the other side. That way it becomes 0 on this side. And over here you just rewrite it. X squared minus 4x plus 15 equals 0. So immediately I would try to do this. That's my first thought. What times what is 15? That if I add together is negative 4. 5 times 3? No, that would give me 8 if I add it, not negative 4. So yeah, it would not work. I would not be able to factor it. So I would have to use the quadratic formula as well right here. The A value is 1. The B value is negative 4. The C value is 15. So let's use the quadratic formula. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. And of course, when we use that quadratic formula, let's begin using it with the parentheses instead of the actual variables. So let's plug in our a value of 1 right here and right here. So that'd be a 1 right there and right there. Our b value happens to be negative 4. Plug it in right here and right there. So negative 4 right in there and negative 4 right in there. And the c value happens to be 15. So let's put a 15 right there. 15. So again, when we use the quadratic formula, let's begin by doing the discriminant value. Start with the inside of the square root. That's a positive 16. And then minus 4 times 1 is minus 4. Minus 4 times 15, that's negative 60. Isn't that right? So it's a negative 60. So inside the square root, my discriminant will actually be a negative 44. Yeah? Perfect. So I really have a negative 44 as my discriminant. So let's rewrite the whole thing. Instead of minus 4, I'm just going to put x equals positive 4 plus or minus the square root of, you just said it was negative 44. So I already know that I'm going to get imaginary answers. Visually, that means that my parabola will not cross the x-axis. It's still all divided by 2. But let's get the exact imaginary answers that are correct to this equation. So we're going to take the square root of negative 44, and right here on the side, I want to simplify it. I know that that negative is going to come out as an imaginary. I know that the 44, I'm going to break it down to 4 times 11. The square root of 4 is 2, so I really have I times 2 times the square root of 11, which means I have 2i square root of 11. Okay, so I'm going to replace the square root of negative 44 with 2i square root of 11. So let's replace it. Let's rewrite it. We really have 4 plus or minus 2i square root of 11, all divided by 2. So what should I do from here? I mean, this is the correct answer, but it's like a fraction that's not reduced. I need to reduce. So I reduce everything by what? by 2. So this divided by 2 is 1. This divided by 2 is 2. This divided by 2 is 1. So what I really have is x equals 2 plus or minus 1i, or I could just put I, square root of 11, over 1. So I don't need to put it over 1. That's my final answer right there. So the quadratic formula will work on anything. So down here, they want you to state a bunch of different things. I just say, use the quadratic formula. It's going to ask you for the discriminant. It's going to ask you for describing the number and type of roots, right? So how about this, number 15? I could use the quadratic formula, but what's an easier method to solve this guy? Factoring, right? What times what is positive 64 that if you combine together is negative 16? Negative 8 and negative 8 equals 0, right? So at this point, you could write it as a binomial squared, which will be x minus 8 equals 0. And you could square root. You'll have x minus 8 equals plus or minus 0. So all you got to do is add 8. You'd have to rewrite it. X equals 8 plus or minus 0, which is not going to give you two different answers. If you add 0 or subtract 0, it's still going to give you the answer 8. So your answer is 8. Okay, now what does that mean? If I were to graph this parabola, we know it's opening up. We know that the pattern's 1, 1, 2, 4, 3, 9. How many times would this parabola that opens up cross the x-axis? Once. Where would it cross it? It would cross it at the x value of 8, to be specific. All right? So they wanted us to find the discriminant. I guess you have to do the b squared minus 4ac to find the discriminant. Describe the number and the type of roots. Well, I know that there's only one real answer. So there's one exact solution, whether you use a quadratic formula or not. Okay? So if you could use something else, you could use something else. If not, go back to the quadratic formula. 17, I would for sure use the quadratic formula. Same thing with 19. I guess all these quadratic formula because none of them are easily factored. 15 was easily factored, but the rest are complicated, so I would use a quadratic formula on the rest of these. Is there any one specific one you'd like to see?
Let's do
23, 25, 27, 29.
23.
23?
Sure.
23. So, we'll call this the last one, right? We already know we're going to use the quadratic formula. We know that the a value is 7, the b value is 6, the c value is 2. We know that we need to start with this with parentheses instead of the a, b's, and c's. So let's plug in our b value, which is 6, our b value, which is 6, our a value, which is 7, our c value, which is 2, a value is 7. So we will have negative 6 plus or minus the square root of, let's work on that discriminant. We have 6 squared, which is 36. And then 4 times 7 is 28. Times 2 is 56. So you have minus 56, right? Yes or no?
Yes.
All right, so what's 36 take away 56?
Negative.
Negative 20. So I really have negative 20 as my discriminant. All divided by what? 14. Now, on this section, if you look at the back, it says, what's your discriminant? Well, if you wanted to state it, your discriminant is negative 20. That means it's going to have no real solutions. It's going to have imaginary solutions, complex numbers, I think they say on the back. But we need to actually find those exact solutions, those complex answers. So let's take that square root of 20. Let's do it on the side. The square root of negative 20, that's going to be an I on the outside, and then you're going to break down 20 to 4 times 5. The square root of 4 could be done. It's 2. So you really have I times 2 times the square root of 5. I times 2 is really 2I, and the square root of 5 is at the very end. So my new answer, x equals negative 6 plus or minus 2i square root of 5, all divided by 14. So we still need to reduce. Let's reduce everything by what? By 2. Sure, why not? Let's reduce. So divide by 2, you get a 7. Divide by 2, you get a 3. Divide by 2, you get a 1. So my new answer is x equals negative 3 plus or minus I square root of 5 over 7. Now, to be honest with you, I don't know if they actually separated this answer or not. On the back, did they leave it like this?
They leave it like that.
They leave it like that?
They haven't separated any of them in the back.
Oh, wow, that's interesting. Okay, so I've seen certain test generators that do separate them. They put the 7 on the 3 and the 7 on the I square root of 5. But if they leave it together, then they leave it together.
So will it matter that when we take the test?
On my test, it's open response, so it won't matter. But on the final exam, it's multiple choice. So you need to be able to see that if they actually split it apart on the multiple choice, then identify it, yeah. Okay, so I'm done. You guys could do the rest of this. I do think we're going to have a test on solving quadratic equations. I'll give you a practice test before, but this is coming up this week. So please make sure you practice these problems because I'm selecting right from here.